Time to educate you. Remember, the key thing on this is to find the largest perfect square that evenly goes into the number, or perfect cube. And as it turns out here, 48 is divisible by 16 and 3. I know it's divisible by 4, but you gotta go with the largest perfect square. Square root of 16 is 4. The 3 stays inside. 24, the largest perfect cube, gotta pay attention to that stuff there. Our largest perfect cube is 8, and that's 8 times 3. So I split that apart. The cube root of 8 is 2, and the 3 stays inside the cube root symbol. And then I deal with the 11. 3 goes into 11, let's see here, 2 times, so it's an x squared, but with 2 remaining. And so then you have an x squared both inside and outside there. Down here, I first need to simplify it by multiplying these exponents together, these fractions together. That's actually going to cancel these 2's. As you'll notice, there's a 2 down here and there's a 2 up here. And so it leaves me with 1 over 3, 125 to the 1/3. Well, that's just the cube root. Well, the cube root of 125 is 5. Exactly 5. And here we're dealing with a cube root of negative 27. Well, anytime you're dealing with cube root of, or cube root, fifth root, any odd root, negatives are okay. If it was square root or fourth root, negatives are not okay. Cube root of negative 27 is the same thing as cube root of positive 27, only the answer is negative. So just negative 3. Convert to radical form. Well, that's where nerd comes in. Remember, numerator is the exponent, the root is the denominator, and so I'm going to take the x, and the numerator, 9, is my exponent for this, and the root is going to be the denominator, which is an 11. So it's the 11th root of x to the 9. And with this one, okay, it's raised to the first power. I don't need to write a 1 if it's to the first power. And it's, the root is a 2, the index is a 2. Again, I don't need to write a 2 index, so it's just the square root of w. And I don't have to simplify anything here, just rewriting it. Solving, okay, fraction for an exponent. I'm going to raise both sides to the 2 over 1, because that's the reciprocal. And 2 over 1, that's just 2. I'm just squaring both sides. So I'm going to square the left side, I'm going to square the right side. That cancels my fraction here, leaving with just the x minus 11. And the right side, 5 squared is 25. So add the 11. I get 36. That's my answer for that one. On number 8, I just need to cancel the squared by squaring both sides. Here I'm going to have to FOIL. So on the left hand side I just have regular x plus 18. But on the right hand side I need to FOIL out x minus 2 times x minus 2. Because it's not just x squared plus 4. I'm not just squaring the first thing and the last thing. I have to actually FOIL it. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is also negative 2x. And negative 2 times negative 2 is positive 4. Well, then simplify that, and I've got the x squared. Makes a minus 4x in the middle, and a plus 4 after that. Now I need to solve this. It's a quadratic equation, so I need to get everything to one side and factor it. So I'm going to subtract the x. That'll give me a negative 5x. I need to subtract the 18, and that'll give me, let's see, that'll give me negative 14. And so then factoring that, my multiply number is negative 14, my add number is negative 5, and the numbers that do that are going to be negative 7 and positive 2. You can double check that, but those are it. So then I write that as x minus 7. times x plus 2. From that, my solutions are positive 7 and negative 2. Now I do need to go back and plug in these numbers to check which one is extraneous. If you don't cross out the extraneous solution, it is incorrect because extraneous solution is not an actual correct solution. Most of the time the negative number is the extraneous one, so I'm going to start with that one. If I plug negative 2 back into the original problem, then I would have square root of negative 2 plus 18 is equal to negative 2 minus 2. Again, I just took negative 2 here and I plugged it into both of these x's. That's all I did. Now I'm going to simplify that. Negative 2 plus 18 is 16. Negative 2 minus 2 is negative 4. The square root of 16 is 4. Does 4 equal negative 4? No. Therefore, this is an extraneous solution, and sure enough, that one does work out okay down there. But you should always check both. And they're not always going to be positive or negative, like you got to check by plugging both of them in. Okay, a couple questions here. Solve using the quadratic formula. So remember that that is negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, there's a problem here. I can't just start plugging things in because it doesn't equal 0. So I'm going to have to move this 2x to the other side, and it needs to go in the correct order, so that's in the correct ABC order. I'm going to add the 2x over there, so it'll be a plus 2x, but it's going to be in the middle of all that stuff. So we've got x squared plus 2x plus 14 equals 0. Now that it's rearranged correctly, then it can be solved. My a is 1, my b is 2, and my c is 14. So we take the b, we plug that in. Remember, it's negative b though, so I put the negative sign and then I put the b in value in there. Plus or minus b squared minus 4 times 1 times 14 all over 2 times 1. Negative 2 plus or minus. Well, let's see here. Let me just pull up the calculator real fast. 2 squared minus 4 times 1 times 14 is, oh, whoops, 14, there we go, is negative 52. Alright, and so then square root of negative 52 over 2. Well, as far as this goes, negative 52 doesn't simplify perfectly, so I'm just going to leave this as an imaginary number. Negative 2 plus or minus I root 52 over 2. And we'll just leave it right there. Do remember that I expect, if there's a negative sign inside your square root symbol, that you pull it out and call it an imaginary number there. I want to see that you know that. The next one, what is the index of this expression? It's the 7. The index is the tiny little number there, part of the root. So the index is 7. Here, if x equals 3 and x equals 0 are solutions to this equation, then which one is extraneous? Okay, so the best way to do that is to plug both of these numbers in and see which one fails. If I plug in 3 plus 1 equals, okay, so 3 plus 1 is 4. 3 minus 1 is 2. The square root of 4 is 2. Does 2 equal 2? You betcha. So it seems like this one works out a-okay. Then I plug in 0. 0 plus 1 equals 0 minus 1. Let's see here. 0 plus 1 is 1. 0 minus 1 is negative 1. Square root of 1 is 1. Does 1 equal negative 1? No. So then that means that x equals 0 is my extraneous solution. Keep in mind here, because we were looking for extraneous, then x equals 0 is the answer we were actually looking for. Then, this one here, y'all seem to have trouble with this on the quiz. It's real simple. Just, I'm given a formula, I'm given a value for one of these two unknowns, plug it in, and then solve for the other unknown. So 7.1 is v, I just replace that, and now I solve for r. Well, the pi is not inside the square root sign, so I'm going to have to multiply both sides by pi, times pi. Okay, cancel pi, and then let's pull that calculator back up. 7.1 times pi is 22.305. Okay, so I've got, what did I just say that was? 22.305. I'll just write around this for now. 22.305 is equal to the square root of 13r. Well, now to cancel square root, I square both sides. So coming back to this number, I'm just going to square that. And I get 497.5. 497.5 equals 13r. Divide both sides by 13, and I get, let's see here, I get 38 point, we'll just round that to 38.3. So r equals 38.3. Not so hard, really. It's just a matter of plugging it in and what, canceling the pi, canceling the square root, canceling the 13, whatever. Pretty straightforward, pretty simple. Last two questions. Find the inverse of this. Alright, well, to find the inverse first, I'm going to treat this as a y, and I'm going to swap my x and my y. So now I've got x equals 1/3 times the quantity y plus 2. Then I'm going to cancel, it looks like two things. I've got to cancel the 1/3, and I've got to cancel the plus 2. Well, the 1/3 is multiplying. To cancel a fraction that's multiplying, you multiply by the reciprocal, 3/1. Hey, 3/1, that's just 3. Okay, so I'm multiplying both sides times 3 to cancel the 1/3 there. Multiply by the reciprocal to cancel a fraction that is multiplying. On the left-hand side, I've got 3x. On the right-hand side, I've got y plus 2. To cancel the plus 2, I need to subtract 2. So I get y equals 3x minus 2. Alrighty, last one here. Given f is this, g is that, find g of f of 3. Now remember, you're plugging the 3 into the function that it's closest to, so that's the f function. 2 times 3 minus 1 is 6 minus 1, so that's 5. So now I'm going to take that answer and plug that answer into my next function, g. So g is x squared plus 5. I'm going to replace the x now with this 5, and so that's 5 squared plus 5, which is 25 plus 5, so that makes 30. And that means that 30 is my final answer there. Alright, good luck tomorrow.